Hello everybody, good afternoon, welcome to Build Before Sixth Form College. I'm Martin, you've seen me before in lots and lots of videos. I'm here back in the lab and I want to do a little bit of a science experiment for you, since it's nearly Christmas. Now, we're all going to be looking forward to our Christmas dinners, and two of the main components of a Christmas dinner are stuffing and, make sure I get the right way around, and gravy. Other brands of gravy and stuffing are available, by the way. Now, stuffing and gravy form part of your Christmas dinner, and one of the important things for your Christmas dinner is to have a balanced diet. Now, on the molecule type tree here, as you can see, we've got lots of nice molecules. Now, one of the main food groups is fats. So here's a lovely big long chain fatty acid, lots of energy in those carbon-carbon bonds. And another one of the major food groups is one down here. Here's an amino acid. It's an amino acid. It's got the amine group and the acid group there. These are the backbones of proteins. I'm not interested in proteins or fats this afternoon. I'm interested in this. This is glucose, C6H12O6. Now, glucose is the fuel that runs your body. It's the fuel for respiration. It allows you to grow, allows you to move, and it's found particularly in these foods in the form of starch. Now, what I'm doing here is I'm doing an experiment. If you want to come over and have a look at my water bath, this is quite exciting. I've made up some gravy and I've made up some stuffing, and what I want to do is I want to analyse how much starch is in them, but I want to do a little bit of a difference. I've set up a couple of model guts here. Now, this looks a bit disgusting, but I've got the stuffing here and the gravy here inside visking tubing. Now, this is a model gut, okay? So what I'm hoping for is that the contents of the gut is going to be like what goes on inside you. But just to add a little bit of extra, I've put some of this in. This is amylase. This is an enzyme you produce in your saliva and you produce in your intestine, and this will break down starch, break down the carbohydrates into the sugar. So what I'm hoping to demonstrate is the fact that gravy, meant the G, gravy and stuffing contain lots of starch. But when treated with this enzyme in my water bath at about 37 degrees blood temperature, that the starch will get broken down. So let's do the first stage of the experiment. Now, I've got some pipettes. So one in the stuffing, one in the gravy, one in the stuffing, one in the gravy. And I'm just going to do 6 little quick experiments now, and then we'll do the same for finding out the sugar. Now, I've got some test tubes here. So I've got starch before, stuffing before, stuffing after, and stuffing after outside. Now, so let's do the stuffing ones. So, bit of stuffing in there, bit of stuffing in there. Now, what I'm doing is I'm taking the liquid from outside the gut. So you can see it's quite clear, and I'll do the same with the gravy. So the outside, so this is the gravy before digestion, this is the gravy after digestion, and this is the gut content outside, which would represent your blood. Now, to demonstrate this, we're going to use iodine. Now, iodine is a test for starch. We do this at school, but we do this again as part of A-level biology and BTEC science, and that should go really dark blue. Look at that. There you go. There's a nice positive. So we know we've got starch in the stuffing, the starch in the stuffing in your gut, but you won't find starch outside in the blood. So the starch has not left the gut. It's too large a molecule. Let's see if the same is true for the gravy. The gravy, very starchy, blue-black, being an A-level biology student. And again, the gravy in the gut hasn't been broken down. Well, it will have been broken down a little bit, but let's see if any of the starch has escaped the gut. This shows that large molecules, like starch, which is basically lots and lots of those glucose molecules, thousands and thousands of them, all stuck together end to end, has not been able to leave the gut. However, glucose is a small molecule. What I want to test now is to see if it's been broken down. Sorry, the starch has been broken down into glucose. Let's see if we can find glucose either in the gut contents or elsewhere. Again, more tubes. So, get it right. Stuffing before, gravy before. So there we go. So gravy before. We're going to test this for sugar. And I'll tell you what the test for sugar involves. Is basically the Benedict's test. Now, so we got after digestion, and then the water in the outside, this represents the blood, And we'll do the same for this here. So there we are, there's the gravy from the gut and the gravy from the outside. Now, Benedict's is this blue solution here. It's copper. It's copper 2 ions. We just put a small quantity in each tube. Okay, so you can see it's a lovely rich blue colour. Now, those are copper 2 ions. What I'm hoping is that the glucose is what we call a reducing sugar. The glucose is going to react with that copper 2 and make it go bright red. So let's see if this works. Now to do this, I've got to put it in some boiling water, so really careful. So I've got my visor on, let's be safe. Got a kettle here just boiled. It's like Blue Peter, isn't it? Is what I heard earlier with the scientific content. Nearly there. It's important if you're a student and you have to write up about the Benedict's test, it's important that you say that the water isn't just hot, but it's nearly boiling. Now, so it's nice and safe. Nice beak of warm water. Pick it up in a towel. Safely put it down here. And so here's my tubes. So I've got the stuffing that's been in the gut. And I've got the stuffing that's representing the blood supply, representing the blood outside the gut. Same with the gravy afterwards. And what we're looking for is a nice brick red, orange colour developing. And this should develop very quickly with a little bit of luck. So let's see if this is going to work. Now if you read the packet you can find out lots and lots of ingredients, and it actually does say that wheat flour is starch, and then there's lots of vegetable oil as well, and they're pretty much the same for these, but there's nothing wrong with it. It's good to eat, it's good stuff. So gravy afterwards. This is the important one. Gravy afterwards outside, no sign yet, but it may take, oh there you go. Now you can see that there's a lovely formation there. Did you see there's like a brick red precipitate? That shows that some sugar has actually left from the stuffing. The sugar has actually been produced inside and left and gone outside into this liquid here. So you can see it's clearly there, because it would normally have just stayed that colour. So that's a nice positive result, and there you go, the same for the gravy. So this shows that the starch gets broken down, then gets moved out of your gut into the blood supply. And there's a nice simple experiment that you can try to demonstrate what happens to your Christmas dinner. So all the good stuff in the stuffing, in the gravy, gets broken down your gut, puts into your blood, and then that basically goes into respiration and allows you to live, allows you to grow, and allows you to enjoy the rest of your Christmas. Now, that's enough from me here at Wilberforce Sixth Form College. I'd just like to say, all look after yourselves. I know it's difficult times at present. Keep your chins up, look after yourselves, but most importantly, look out for each other, look after each other. And remember, everybody here at Wilberforce Sixth Form College is looking out for you, and we look forward to seeing you next year. So in the meantime, have a really Merry Christmas, very Happy New Year to you all and your families. Bye-bye now.